was that? Since when was chemistry so hard? I did not understand a single thing about the quantum model or the Bohr model.
Me too. We learned this in high school, right? But why is so different?
Yeah, like the Bohr model is already perfect as it is.
Yeah.
Why did scientists have to create the quantum model?
You two feel like the Bohr model is perfect because you guys don't know the questions and problems involving it. All you guys have is your limited high school knowledge.
You talk big for someone who entered university the same time as us. If you understand the quantum and Bohr model so good, then why don't you explain to us?
Easy. Before that, you have to know at least the history behind the two models.
Welcome back, students. Please get ready to learn more about this topic. So let's us hear about this interesting topic, which is birth of the quantum model. In 1924, Louis de Broglie reasoned that if light waves can behave like particles, then particles like electrons can possess wave properties. This theory is well supported by other experiments. In 1927, Heisenberg mentioned it is impossible to determine accurately the momentum and the position of a particle simultaneously. 1925 until 1933. Mathematical equation that explain electron density and the atomic orbital by Schrödinger's wave function.
So basically, the quantum model is the more advanced and perfect version of the Bohr model.
Yep, that's right. Okay, how about we start from the very basics? The key differences between the quantum model and the Bohr model is that quantum model is basically the solution to Bohr model's limitations. As Hani said before, it is a more perfected Bohr model.
Analogy: school seating versus free movement. Bohr model is like a classroom with fixed seats. Every student must sit only in specific numbered seats. You know exactly where each student is sitting at all times. Simple, organized, but not very realistic. This is Bohr's idea that electrons move in fixed circular orbits around the nucleus. Quantum model is like a school during recess. Students don't stay in fixed seats anymore. They move around near the canteen, hallways, or benches. You can't say exactly where a student is, but you can say where they are most likely to be. This is like the quantum model, where electrons don't have exact paths, only probability regions inside the orbitals.
There are many real-world applications of the quantum model, such as GPS navigations. So have you ever wondered how your phone knows exactly where you are? High above Earth, more than 30 GPS satellites constantly send signals with precise timestamps. Your phone listens to these signals from several satellites at once. By measuring how long each signal takes to arrive, your device calculates the distance to each satellite. Then use a method called triangulation. It finds the exact point where those distances meet, which is your location exactly. Once your position is known, GPS can guide you step by step to your destination. Next up is MRI scanners. How can doctors see inside your body without surgery? MRI, or it is also known as magnetic resonance imaging, uses powerful magnets and radio waves because our bodies contain a lot of water. They also contain hydrogen atoms that act like tiny magnets. When you enter the MRI scanner, a strong magnetic field lines up these atoms. Then radio waves briefly knock them out of alignment. As the atoms return to their original position, they send signals that the MRI machine detects. A computer converts these signals into detailed images of organs and tissues, helping doctors see what's happening inside your body.
Oh, so that's why they didn't choose the Bohr model. So that is also the reason why they created the quantum model. I understand now. There's so many problems about the Bohr model.